Can you answer the questions like, if two forces working on an object at angle theta, then what will be the magnitude and direction of the resultant force? Or a river is flowing toward the east direction with velocity v1 and a boat is trying to cross the river moving in north direction at a speed v2. What will be the speed and direction of the effective motion of the boat? Answers to questions that involve quantity vectors in two directions can be easily given by parallelogram law of vector addition. If two vectors are represented by two adjacent sides of parallelogram, here the sides are OA and OB, then the diagonal of parallelogram through the common point O represent the sum of two vectors in both magnitude and direction. Now let's see the derivation of parallelogram law of vector addition. There are two vectors, vector A and vector B. These vectors may be representing a vector quantity like force, acceleration or velocity. To find out the resultant vector or resultant vector quantity, draw these two vectors as two adjacent sides of a parallelogram and complete the same by drawing the parallel lines to these vectors. Resultant vector is given by the diagonal of this parallelogram starting from point O, which is a common point between two adjacent vectors A and B. Now let's put a normal from point C to the direction of vector A that intersect the extended line OA at point D. Here you see the two right angle triangles ACD and right angle triangle OCD. By using these two right angle triangles, we will establish the magnitude and direction of the resultant vector. From triangle ACD, by using the trigonometric functions like cos theta is adjacent to hypotenuse, adjacent side to the hypotenuse of the triangle. Sin theta is opposite side divided by hypotenuse of a right angle triangle. So here ACD is a right angle triangle. So cos theta is equal to AD divided by AC. By using this relation, we can write down AD is equal to B cos theta. Similarly, the length of CD is given by B sin theta. Now by using the another triangle, the right angle triangle OCD, and using the Pythagorean theorem, we can say that OC square, which is a hypotenuse square, is equal to the base square, which is OD square, plus CD square, which is the height of the right angle triangle. But OD is equal to OA, this is OA, plus AD. OA is vector A, its magnitude is A, and AD we can take from here. So here, by putting the value of these sides, we can write down here OC square is OA, OA is A, and AD is B cos theta, and CD is B sin theta. By simplifying this equation, we can reach to this particular equation where cos square theta plus sin square theta, as per trigonometric functions, this value is equal to 1. So by putting the value of cos square theta plus sin square theta as 1, we get the magnitude of the resultant vector C. Magnitude of C is equal to the square root of A square plus 2AB cos theta plus B square, where A and B are the magnitude of vector A and B, and theta is the angle between these two vectors. So this way we got the magnitude of the resultant vector. Now let's see how we can get the direction of this vector. If resultant vector make an angle alpha with vector A, then by using this triangle OCD, we can write down that tan alpha is equal to CD, which is a height of the right angle triangle divided by the base of the right angle triangle. So tan alpha equal to B sin theta divided by A plus B cos theta. So here AD is basically B cos theta, this length AC is B, and the CD is B sin theta, right? And by symmetry, if the resultant vector make an angle beta, which is in this case here, with vector V, we can write down that tan beta is equal to A sin theta divided by B plus A cos theta. So here B is the vector with which the resultant vector makes the angle beta. In previous case, alpha is the angle between resultant vector and the vector A. So if you have any problem where you have a vector quantity and there are two vectors at angle theta for that quantity, you can find out the magnitude and direction of the resultant vector of that quantity by using this parallelogram law of vector addition. Okay. Now let's take a few examples from real life situations. So two forces of 4 Newton and 3 Newtons are working at 120-degree angle on an object. Here the vector A is the force F1 and the vector B is the force F2. The angle between these two vectors is 120 degree. So here we can use the parallelogram law of vector addition to find out the resultant force on this object. We can complete the parallelogram by drawing the parallel lines to these vectors, and then the resultant force can be given by the diagonal, which is start from the common point of these forces, and it's given by F here. The magnitude of this vector and the direction can be measured by the actual drawing on a scale by measuring the length of this vector and the angle alpha here. And the same thing can be find out by using the formulas which we have derived. So here force F square is equal to F1 square plus 2F1 dot F2 dot cos theta plus F2 square. We can put the values, and by solving this equation we will get the value of the resultant force or magnitude of resultant force is under root 13 Newton. Now we can find the direction by using the formula tan alpha. Alpha is the angle between the resultant force and F1, and by putting the values we will get the value of tan alpha as equal to 3 under root 3 by 5, and the value of alpha is tan inverse 3 root 3 by 5 in degrees. Now let's consider another example. Here in a river, water is flowing with the velocity 2 meter per second in east direction, and a motor boat is moving with the velocity 4 meter per second due north, which is at 90 degree to the motion of the river. Now we have to find out the resultant velocity of motor boat, the velocity relative to an observer on the shore. Here vector quantity is velocity, velocity of river and velocity of boat. Both of these velocities are at angle theta, which is 90 degree in this case. So if we complete the parallelogram by drawing the parallel lines, we will get a rectangle in this case, and the diagonal which is from the common point of these two vectors will give the resultant velocity v of the boat. Here you can see the boat will be moving along this diagonal and will reach to the another side of the river as per the observer who will see from the ground. The magnitude of this velocity or speed of the boat can be given by formula, and here cos 90 is 0, The speed of the boat is under root 20. And the direction of the boat is given by tan alpha, where alpha is the angle between the resultant velocity and the direction of the river flow. By solving this, you will get the alpha angle, which is angle between the direction of the motion of the river and the boat actual motion, is equal to tan inverse 2. And that's all we have for today's session. I hope you would have enjoyed this session. If you think you have learned something new today, then please click like button and put your comments and suggestions in our comment box, and subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.